Hello guys, welcome back to Math Zone African Motives. In this case, we are going to consider as our basics, which is the part of actually a revision in order for us to have a start or to start up our trigonometry. We need actually to understand some of the basics that we had from our grade 11. So in this case, we are going to consider the trigonometrical ratios and as well as application of the Pythagoras theorem, which is an important aspect as a startup, like I said. We are going to consider all the sections that we have in our syllabus. So as an individual, you must follow up the playlist that you are going to be having so that you can watch from the first video up to the last one, as we are going to consider according to your syllabus. But this one, if you are to check according to your ATP, you're going to find out some of the aspects. They are not going to list them because they understand that you have done them previously in your grade 11. And also remember, in your grade 10, you also had the part of what? Trigonometry there. So in our case, we are going to focus with the basics that we need, which is the first aspect, application of our trigonometrical ratios. Trigonometrical ratios. So this aspect, like I said, is not the first time you have done or you have worked with the trigonometrical ratios. But now in our case, we are not going to consider the 6 trig ratios. We are not going to talk about the 6 trig ratios as we had them previously. Remember, in your grade 10, you had the 6 trigonometrical ratios. But in our case, guys, we are going to simply work with the ratios of sine of theta, the cosine of theta, and the tangent of theta, which is the tan of what? Of theta. Those are the 3 that we are going to be working with, which are to be taken in a right angled triangle. So remember that in a right angled triangle, all right, one of the angles being 90 degrees, we are given the remaining 2 angles which must add up to 90 degrees. So of these angles, we are simply going to name one of our angles as what? As theta, which is the angle that we are going to be working with. So we are going to name this angle theta. This angle theta. It is according to the angle theta that we can name the sides of the triangle. So if my triangle is referred to as A, B, C, let's say this is our triangle. The side AC, the side BC, the side AB, they are taken according to the angle theta. According to that angle. Meaning to say, if your angle was here, it was going to be something else. The way that we view this side, the way that we view this side is according to the angle that you're given. So in our case, according to our angle theta, the side which faces that theta, remember, it is your opposite. So there we have got the opposite. The angle theta and the 90 degrees, they are adjacent to each other. So therefore, the side BC is referred to as the adjacent. And always remembering that the longest side is the hypotenuse. The one that faces what? The 90 degrees. The one that is always facing the 90 degrees is your longest side, that is the hypotenuse. This is our case. So if it was taken, this is very, very important aspect that you must consider, guys, because we are going to be using this later on. In this triangle, if our angle theta was here, on this point. This is our angle theta. It means according to this theta, this side which faces theta will be our opposite. Whereas the adjacent side where theta and what? 90 degrees are sitting next to each other. That is your adjacent. And the longest side always facing the 90 degrees is our hypotenuse. So it is only the hypotenuse which is not affected because of what? Because of the angle that you are referring to. The hypotenuse is not affected. It is always facing what? 90 degrees. But the other sides now, for you to mention, to say this is opposite, this is adjacent, you mention according to the given angle. You do not just mention, say, I just want this one to be my opposite. No, there's no way like that. It is opposite to which angle? All right. So given this right angle triangle, guys, it follows that these three trigonometrical ratios can be obtained. Remember, before you used the mnemonics SOHCAHTOA, this SOHCAHTOA concept to determine these trigonometrical ratios, which gives us that the sine of the angle is equal to the opposite over what? The hypotenuse. So meaning to say, we can have these trigonometrical ratios according to this concept. Number one, the sine of the angle theta is equal to what? Opposite over hypotenuse. So in our case, according to our diagram, our opposite is what? AC, and our hypotenuse is what? AB. So here we're just naming according to our diagram. So that's our opposite, AC, over what? Our hypotenuse, which is what? AB. Just like that. Same thing, the cosine of theta, the cos of theta is equal to what? Adjacent over the hypotenuse. Adjacent, which is the side BC or CB, all right? That is, all right, let's just have our formula first. Adjacent over what? The hypotenuse. So our adjacent is the side BC, and our hypotenuse is what? AB. Same, the tan of theta being opposite over what? The adjacent. We can have that. Opposite over adjacent. You substitute what represents the opposite side AC. What is your adjacent? The side BC or what? Or CB. This is what we have. According to the given diagram. The SOHCAHTOA concept can be what? Can be used to find the sine, the cos, and what? The tan of the angle that is given. So realizing that you are working with the angle theta, there's an angle involved there. In fact, there are angles involved because also A can be determined if you know the value of what? The value of theta. So meaning to say, whenever I'm given a condition where the trigonometrical ratios are to be used, the question can be to find the given side, which is the length of any side. So we can be used to find that, right? Can be used to find length, which is the length of any given side. Also, it can be used to calculate or to find angles to determine the value of a certain angle. Guys, with our manipulation, change of subject, we can work out whatever that you are asked there. So I'm going to show you how to attempt typical questions applying of what? The trigonometrical ratio. So like I said, guys, this is not the first time that we are referring to this. So we are simply going to rush to the next aspect, which is Pythagoras. Then we are going to look into the examples of these two. So we also have the application of our Pythagoras theorem. Remembering that for us to apply this, it must be in a right-angled triangle. So given a right-angled triangle, let us just call this right-angled triangle ABC. So given a right-angled triangle like this, it follows that the hypotenuse square, the square of this hypotenuse, is supposed to be equal to the sum of the squares of these two shorter sides. Remember, the hypotenuse is the longest side. And we have got the two shorter sides that are remaining. So using that concept, all right, this is angle C, this is side C. This is angle B, this is side B, the one that faces what? The given angle. This is angle A, this is what? Side A. So it follows that if I am given this condition, the Pythagoras theorem from the hypotenuse square being equal to the sum of the squares of what? The two shorter sides. It must be equal to a squared plus b squared. The hypotenuse square, c squared, is equal to a squared plus b squared. There is no involvement of the angle in order for you to use Pythagoras. It is about the sides. So given two sides, I can calculate the third side from what? Pythagoras. I just have to play around with this formula. So as long you are given two sides and you want to calculate what? So you're saying as long you're given what? Two sides. All right? Calculate the third side. Calculating what? Calculating the third side. The third side. In that case, Pythagoras is the perfect formula to be used. You just have to play around with the formula. All right. So like I said, guys, here we are just having what we call a recap. So we're not going to waste our time. This is what you're going to need. The part of your definitions. All right. The trigonometric ratios are for what? Right-angled triangles. These ratios all involve one angle other than what? The right angle. And the length of what? Of two sides. So we saw that if it is a ratio of a sine, the ratio of a cos, it is the angle to the given side. Is it AB over AC? Is it? So two sides must be what? Must be included in a ratio. The ratios can be used to find length of a known side or an angle and the other two quantities, if the other two quantities are known. This is what we're trying to refer to, use to find length and what? And angles. So in that case, we can use trigonometrical ratios as an aspect to find what? The length of an unknown side or an angle if the other two quantities are known. Then we refer to the Pythagoras theorem, which is, it states that for any right-angled triangle, it must be a right-angled triangle. The square on the what? On the hypotenuse is equal to the sum of the square of the other two sides, which are the shorter sides. So this is our Pythagoras. And thus, the converse now of the same theorem, which is our Pythagoras, the converse, for us to say we have got a right-angled triangle, it must be that if the square of the longest side of the triangle is equal to the sum of the square of what? The other two sides, then the triangle must be what? Must be a right angle triangle. That's the converse. So if I am given a certain triangle, let's say we are not given any angle here, then this side is 3, this side is 4, this side is what? Is 5. I simply have to test that is that true that the longest side, which is 5, if I am to square it, is it equal to the square of what? These two shorter sides, 3 squared plus 4 squared. If this is true, therefore this triangle is a right-angled triangle. That's the converse now. That's the converse. So it's either you are given it as a right-angled triangle, or there is something that matches what a right-angled triangle does on the application of the Pythagoras. Therefore, you can say the triangle is a right-angled triangle. That's our Pythagoras theorem from that statement that we had. If we are given our triangle as ABC, we can conclude that the hypotenuse, all right, in our case, is going to be AB. In our case, this was C, this was A, this was what, this was B. So this formula here, guys, that we are given is just according to the way that you have got your diagram. So in our case, this one, let's just put it this way, because here it is according to your diagram. So according to our diagram, it follows that our hypotenuse is what? Is AB. So I'm going to take that one as AB squared. AB squared must be equal to what? AC plus BC squared. All right. So that's AC plus BC squared. From that, C squared is equal to the shorter sides, A squared and what? And B squared. So that's it. This our Pythagoras. So in order for us to apply these in our two-dimensional problems using trigonometry and Pythagoras theorem, the first thing, if you are not given a diagram, draw one yourself. You do not have a diagram, then make sure that you have to draw it. Make a sketch of the information that you're given. Mark all right angles on the diagram and fill in the figures for any other angles and what? And lengths that are known, the ones that are given. You must indicate them, mark them. Then after that, you must mark the angles or sides that you have to find, which is what? The unknown that are to be calculated. To be calculated. They asked you to calculate the length of this. Mark that length, mark that side, mark that angle. As you have marked the ones that are known, also mark those ones to be determined, to be calculated. Identify the right angled triangles that you can use to find the missing angles or what? Or sides. Identify the right angled triangles. That is, you must decide what mathematical method you will use. Is it the Pythagoras theorem, or is it the application of what? The trigonometrical ratios, the use of the sine of theta, the cos of theta, the tan. Are you going to use any one of those two? Then later in the problem, if you have to use a value that you have calculated. This is most important because we have been answering question papers, and guys, because of you, be just trying to suit to what you also understand because of not having these introductions. But now that you've got introductions, it follows that we are going to follow according to what we are having here. So they are saying if you are to use a value that you have calculated before, use the most accurate value. You must use what? The most accurate value. That is, you must use exact values that is on your calculator. So it is best for you to store your values. You must store your values. Store values on your calculator. You must store them. Okay, I'm going to present that one, how to do that. And you also have to recall those values and only round off at the end. So this is what I was saying. Because of not having these introductions, we'll be trying to suit what you understand. So you check out some of the questions. We had 1.11, or whatever that we had. Then we've got our answer is 28.03. Then we used that value as it is on the next question instead of using the exact value. So under exam condition, they are going to mark you. They are going to mark that. They are going to have answers which are meant for those who followed the two decimal place concept or those who used the most accurate value. So for you to be on the safer side or the safest side, use the most accurate values, meaning to say store your values in your calculator so that you've got what? Exact values, or use the answers as they are from your calculator. Take it as it is. Okay, so that is it, guys. We are going to look into just one or two questions for us to catch up with what we have just referred to as our basics. So in our case, we are given a simple sketch. Use the sketch below. Number one, write down the trigonometric ratios of angle B and angle C. So in our case, if we are to look properly here, we are going to see that it was actually going to be difficult for you to say you're going to calculate all the length of the side that you're given. So here they just wanted you to have these trigonometric ratios in terms of the sides also. Just use the what? The sides. So angle B, according to angle B, this is our angle B here. What are the trigonometric ratios according to our syllabus? All right. So according to our syllabus, remember, that's the use of what? Your SOHCAHTOA. Just like that. That's our SOHCAHTOA concept. So meaning to say, in our case, we are going to have the sine of angle B, which is here. The sine of what? Of angle B. In a right angled triangle, it's opposite over what? Hypotenuse. Remember, this is 90 degrees. This is also 90 degrees here. So it follows that we are actually having what? Triangle ABD as a what? As a right angled triangle. So in this case, for angle B, all these ratios that you're going to have, we are going to focus in triangle what? In triangle ABD. This is the triangle that we are going to simply use. All right, triangle ABD. So using triangle ABD, it follows that according to angle B. Remember I said you name your sides according to the angle that you're given. We are given angle B. So according to this, AD is our opposite. So it follows that we have got the opposite. BD adjacent. Angle B and 90 degrees are adjacent to each other here. So that's our adjacent, and definitely the one that faces the 90 degrees becomes our hypotenuse. So here, guys, it's 90. Remember, angles on a straight line, they add up to 180 degrees. So this is it. So the sine of B being opposite over hypotenuse, what is our opposite? that's the side AD, over what? The hypotenuse, that's our AB, just like that. So in this case, they just wanted you to have them as what? As ratios like that. Do not substitute anything. We also have the cos, adjacent over hypotenuse. So it follows that the cos of angle B is going to be adjacent, which is what? Our BD, over the hypotenuse, which is what? AB. All right, just like that. Then the last one being the tan of theta. So the tan of angle B, which is our theta, in this case it's angle B, is what? Opposite over the adjacent. Our opposite, that's our AD, over the adjacent, which is what? Which is BD, like that. So this is what you're going to have according to this information they wanted you to have answered your question in that manner. So you do the same thing for the other angle that you are given, which is what? The angle C. According to angle C, you name your sides according to angle C in a right angle triangle. So there is a right angle triangle formed, which is what? ADC. So this is the right angle triangle that you are going to use where angle C is. So that's in a triangle ADC. Using this triangle, what is going to be the same trigonometric ratios as mentioned here, the sine, cos, and so on. But of what? Of angle C. So the sine of angle C is going to be what? Like we said here, opposite over hypotenuse. So according to angle C, this is our opposite. All right. So we have got our opposite there, and DC as what? As our adjacent, and definitely the one that facing the 90 degrees as our hypotenuse. So this is it. So opposite AD over what? The hypotenuse, which is what? AC. So that's it. So the cos of angle C is going to be what? Adjacent over hypotenuse. Adjacent, that is our DC or CD, over what? The hypotenuse, which is AC. The same thing for the tan of that angle, just like what we had here. So the tan of angle C is equal to what? Opposite over the adjacent. So our opposite is what? AD. And our adjacent is what? DC or CD. So that's our DC there. We have our ratios just like that. Answer the question, understand the question. All right? It's very, very important for you to understand the concept of the question. All right? On another part of the question, we are now given solve for BD and AB. Solve. You must determine the length of those. So in order for us to solve for BD and AB, in our case, because we have been referring to the application of what? Trigonometry, using these trigonometrical ratios and Pythagoras theorem, we are going to focus on that, on these. We could have even used others. Remember, there's also the sine rule, the cosine rule. In our case, to find the length of AB, this one, we can use the sine rule. Angle to the side, remember. So sine rule can be used. But we want to focus on these trigonometrical ratios as part of our class. So how can we use these trigonometrical ratios? Let's say you're someone under exam, then you want to use those trigonometrical ratios. All right? We can see that BD and AB, they are found in a triangle ABD, in this triangle ABD. And in triangle ABD, guys, there's nothing. There's just an angle there. We are limited in this triangle. In triangle ABD, we are so much limited. We just know that it's a right angle triangle like this. This is our A, this is our B, and this is our D. And there's an angle of what? 47 degrees. That's the only thing that we're given. They want us to determine the other side. So it is impossible without a single side given. If we were given this AD, it was going to be easier for us to determine these two. We can use our trigonometrical ratios. So in ABD, we are limited to find these two. So what are we going to do? Let's determine the length of what? Of AD. From where? This triangle ADC. Like I said, we are limiting ourselves to the what? Trigonometrical ratios, but you could have used the sine rule, which was going to be easier for that part. You can also prove with the sine rule so that we can be on the same side. So in triangle ADC or triangle ACD, there is a side given there. So you can take advantage of that in triangle ADC because there's a certain length, certain side AC given. We have that. This is A, this is D, this is what? C. There is a 15-meter given, and also there's an angle at C, which is 70 degrees. So it will be easier for us to calculate the length or the side AD because it is the same side AD that we have on triangle what? ABD. So from this one, we are going to find or calculate AD. Using the trigonometrical ratios, it is possible according to this angle. We said we must name the sides that we are given according to the angle. What is it that we have? We have got the hypotenuse here. This is the longest side. The side AD to be calculated is what? Is the opposite. Do not worry about DC. Yes, it is the adjacent, but do not indicate that one. Only mark what is known and to be calculated. What is it that you have to find? So there is only one ratio, guys, that has these two, opposite and hypotenuse. That is where now you have to find what are you going to use. Is it Pythagoras or is this trigonometrical ratio? So in our case, the trig ratio was the application where there is opposite and hypotenuse on sine. Soka toa. Opposite hypotenuse. The sine of the angle 70 degrees is equal to what? The opposite. So as you can see, the opposite is the AD, the one that we need to calculate. So that's AD over what? The hypotenuse, and our hypotenuse according to our triangle is what? Is 15, which is AC. Already we have that. So as you can see, guys, by substituting into the formula or into this ratio of a sine, we can see that there is AD as the unknown that is to be calculated. We are now back to equations. This is now an equation. Solve for AD. You can simply cross multiply 1 times AD. That's AD is equal to 15 times the sine of 70. That's 15 sine of what? Of 70 degrees. Never make a mistake, guys, to multiply this. But guys, this is grade 12. You cannot make that mistake. Anyways, that's going to give us the value of what? Of AD. And that's the part now where we explained the issue of our calculator to say The calculator is going to give you actually exact. We are going to have something like this. You round off your answers because of just you want to indicate here the answer for AD. This was what you're supposed to get. But now because of the question paper is saying your answers correct to 2 decimal places, you fix your calculator to 2 decimal places, you get this one as your answer 14 point what? 14.10 meters. Remember that this ain't an exact value. This is not an exact value. It is rounded up. So in order for us to use exact values, guys, we are supposed to store our values. This value as it is, we must store it. So how do I store this one? So it's shift. I press the store this one on recall this. Then I can store in any one of these A, B, C, D, E, F, X, Y, and M. I can store in any one. So I'm going to store in what? In A. In my case, I'm going to use this one. I'm going to store it in what? In A. All right. So I'm going to press that minus. So my answer is now in what? In A. So this is it. So this value, remember, we store this one in what? In A. So on our presentation, we are going to write this, but we use exact values now whenever it is to be used. All right. So our AD, we calculated this. We got this one as what? 14, 10, which is just 14,1 meters. So triangle ADC helped us to determine the length of the side AD, which now we can use it back to this triangle in ABD. Let us determine those given what? Length BD and what? And AB. Just like that, all right? So now, with this one, we can calculate our AB according to the angle that we are given. Angle B there, 47. We want to calculate AB, this one. So AB is what? Is the hypotenuse opposite to what? To 90 degrees. So it is the hypotenuse given the opposite. So that is, we are still back to the use of what? The ratio of a sine. The ratio of a what? Of a sine. We saw that opposite over hypotenuse. So the sine of the angle given 47 degrees must be equal to the opposite, which is the AD 14,1 over what? Our hypotenuse, which is AB. So that is the side to be calculated. That is AB. So this is it. To find AB, as we can see, this is same as over 1. We can cross multiply. So it's AB times this. That was going to be AB times the sine of what? Of 47 degrees being equal to 1 times 14,1. That's 14,1. So to find AB, simply divide by the what? Sine of 47 degrees both sides. This is it. So this was going to cancel. And we have our AB as what? This 14,1. A rounded off value that we obtained here. So remember, we are supposed to use the exact value, the most accurate value. So the most accurate value is not the rounded off value. It is that one that we had to store, this one as it is. So in our case, even if we did not store this value, because guys, we can see that it is exactly the answer that we have. So you can simply say the answer that we have there, divide by what? By sine 47, or over what? Sine 47, just like that. Sine 47. This is it. You can have your answer. Or Since you have got that one, you stored the value in A. So to have that value, it's a shift. We want to recall it. So it's going to be recall A like that. Now there's no, we don't press the shift. It's just recall straight, recall A. No pressing of this shift, just this one, RCL. Recall, you press where you stored the value in the first place. Is it A? Is it B? Is it C? So in our case, our answer is in A. So recall A, this is our value. Over what? Sine 47. So it's over. Sorry, let me put the fraction like this. Then I'm going to say recall A like this. So it shows me that the answer, which is in A, the answer that I stored there in what? In A. Over what? The sine of what? 47 like this. It was going to give us the same thing. That's 19,27 to 2 decimal places. All right. We rounding off this to 2 decimal places is going to give us 19,27. So that's the length of what? AB, 19,27. 19,27 meters. So in case that we are going to use this value, the one that we have as AB, this one, let's say we want to use it, we can store it. Since this one is in A, we can store this one in B. So it's shift, store in B. So our answer now is in B. So this one, if we are to use it later on, we must remember that this answer was being stored in what? In B. This one was in A. So it is up to you. That's when you are using exact values. But even if you just use the rounded off, they are going to mark according to how you applied. So here we used the most accurate value. We had to use the stored value instead, the exact value, not the rounded off. So be very careful. Of which, like I said, do not worry. Even if you forget that, still they're gonna mark you guys, your department guys. It's just like that. They just mark. All right. So this is it. BD. In order for us to determine the length of BD, we can use the Pythagoras since we have got AB here. So we can even use Pythagoras, or we can use the trigonometrical ratios here, because that is, we can even use those cos according to adjacent, or you can use what? The Pythagoras. It was now up to you, because you have the length of what? Of AB. This one, 19,27 meters. So we can apply our Pythagoras theorem to find BD. All right, let's just use Pythagoras since we had it as part of our lesson. So to use Pythagoras, because we've got two sides. Remember, I said Pythagoras is used when you're given what? Two sides, and you want to calculate the third side. The hypotenuse square, the square of the hypotenuse, AB squared, must be equal to the square of what? The two shorter sides, or the other two sides remaining, which in our case, there is BD squared and what? And AD. Those are the two shorter sides. Replace, substitute the values. We calculated AB, we have it. So AB is what? 19,27 squared must be equal to BD, which is the one to be calculated, plus AD. We calculated this. That was 14,1. So we square it. So in order for us to have the length of BD, we can take this 14,1 squared to the other side. Do not simplify. Remember, guys, we're supposed to use most accurate values, not these rounded off values. So we're just going to do it at once. So I'm going to take this to the other side. It's going to be a negative there. Minus 14,1 squared is equal to what? BD squared. So I need the length of BD. I'm just going to introduce the square root. So therefore, our BD must be equal to what? Since we are to use the most accurate values, we are going to use exactly those values that we had to store. Remember, we stored these values, and the 19 0.27, this one was the value, this one that we had to store in what? In B. So it means I'm going to put it like this, square root of what? Recall B, where there is that 19 comma something, that's in what? In B. I square it, minus the 14,1, this one, remember I had to store this value in what? In A, that was our AD. So I must recall A and square it, just like that. So it was going to give us this 13,144 and so on, which is 14 to 2 decimal place. So that's the length of what? Of BD. All right, so our BD was going to be 13,14. All right, 13, that's 13,14 to 2 decimal places. That's the idea there. So in this case, you could even have used any of the trigonometrical ratios there, because you also have AB and what? And AD. So you can choose adjacent over hypotenuse, opposite over adjacent. You can use the ratio of a tan. You can use the cos, the ratio of a cos, to determine what? The length of BD. It was in your hands. But just for the sake of revision, also for us to recap our Pythagoras, we can also use that one. So these are the typical questions as part of your basics. So I want you as an individual to use these basics to answer any other questions that you're going to have. And like I said, it is most important that you can also revisit your grade 11 mathematics on what? On this part. So you can check, there's a playlist that we have for grade 11 mathematics or under the trigonometry part. So you can go through that playlist, see the concepts that you still have in your grade 12, because guys, it is exactly as what you had before, only that we are going to add 1 or 2 later on. So that is it, guys, till we meet again.